Um, and so today we're going to be talking a little bit about more things that you could do client side potentially. And we're going to use this as a bit of a segue into talking about server side which will start next week. More details on that to come next week. But for today, we're going to focus on post and forms. Very exciting topics. Couple of administrative and reminder things. One is homework 2 locks tonight. And so as per usual, that means that afterwards you cannot submit anymore. But I'll also add, same reminder as on Wednesday, the deadline is the deadline, so make sure that when you're submitting things, you try to do so before the deadline rather than at the deadline. Sometimes things take a while, sometimes the internet blips out, so make sure to do it sufficiently before that time. Second thing I want to talk about is a little bit more exciting is the exploration session that we have coming up next week. One of our TAs, Connor, is going to be doing a talk slash exploration session on React. Really briefly, React is another tool that you can use to build websites. We've been talking primarily today about, or this quarter, about all sorts of web programming, mostly client-side JavaScript, HTML, and CSS. And what we've been doing is what we call vanilla HTML, JavaScript, and CSS. And that is, we're not using any libraries or frameworks to do that. React is a little bit different in that it's a framework to build websites. And Connor's going to be talking about that. Time and details will be posted on the website as soon as we finalize them. And so check there. We will also make another post with those details once we post them. So watch for Ed, watch for the calendar. We'll have those details there. Attendance for this thing is optional. However, if you go and then do a short Ed exercise afterwards, you can get some extra credit out of it. So this will be a nice way to kind of learn some more about web development from some TAs who've been doing a lot of work in the area, and also get a couple extra points out of it. So that's that. So getting into the actual content for today a little bit. Just reviewing this notion of a web service. And this is a terminology that we haven't really introduced yet, but it's when we talk about an API that we access over the internet, we often also call it a web service. So this is a service that provides something via the internet using some common protocols, some common ways of talking to each other. And web services are kind of vague, kind of abstract. They can be they can do anything. They can be written in almost any language, but they generally all accept parameters, produce results, and communicate over commonly known formats like XML or JSON over HTTP. And so when we look at using these things, we have a couple ways that we can effectively use them. And one is to know what the return type is. So on Wednesday, we were looking at the NASA Photo of the Day API and verifying that it returns JSON so that we can actually parse it as JSON and then use it as such. But then there's also that check status thing, and that's telling us whether the API, whether when we called the web service, whether it was successful or not. And I'll note briefly that we saw a question on Ed about the linter errors that the check status function was returned. We expect you to not modify the check status, even if it does return those errors. So keep that in mind. So just bears repeating, the check status function, we expect you to not modify it, even if the linter complains about it specifically. Okay. So there's some web services that we've kind of seen already. We got practical hands-on with the NASA Photo of the Day API on Wednesday, and I kind of use the Elephants API, the Random Elephants API, to show off just a different one, which does something different, but it still returns things in JSON, and it is a web service. We also, in the abstract generic sense, have been using this notion of ordering a pizza as a web service API. And soon in an upcoming assignment, you'll see some more web service APIs via this Pokedex thing. And you'll note that .php at the end. We won't have to worry about that pretty much at all. But we'll see what that kind of means when we get into back-end programming. And in all of our cases, these web services are, we can use these web services via some form of fetch. And the common one looks kind of like this, where we have some kind of function. Maybe we're requesting a menu from a restaurant, and we give fetch the API URL plus any kind of query parameters that we might need, and then we go through this chain of thens for the promise. We've seen this a few times. We've worked with promises a lot, so this should be very familiar. And fetch behind the scenes is doing a lot of things for us and a lot of things on our behalf. But mostly, it is making an HTTP request to that particular URL. And when we do an HTTP request, there's a couple of different, what we call methods that we could potentially give it. By default, we use a get method. And all that's saying is, it's basically just saying, issue the same request that I might issue by typing in, oh crap. By typing in a URL into the web browser. So if I type in a URL up here and I hit enter, that's doing a get request. So it's just kind of the internet, the web default for doing an HTTP request. But there are other methods. So if you search the internet for HTTP request methods, there's a lot of information out there about get, post, put, and delete. And those are the main ones. And we pretty much never see put and delete. We won't use them in this class. Most websites don't use them to at least the same extent as get and post. So the question then is, what is post? So get and post are the two most common request methods that you're going to see. Get is primarily used for retrieving information from a server. So it's something that you use to do search queries. You can get an index.html page. You can get the home page for something. You can get another web page. You can get an API response as well. And there's a couple of qualities about it that are really different from post. And the first thing is that every bit of information about the request can be seen in the URL. So, for example, up top here, we have this URL here, and the GET request is all there. We have the host name, which is courses.cs.washington.edu, and then we have a path, which is requesting the particular file that we're looking for. In this case, we're looking for the slide 6 from lecture number 15. And so all of the information we want there is just right there. And it's also something called idempotent. Now, this is a fancy word, and when you go and look at the specification for HTTP, I'll make this bigger, and then go back to there. But when I zoomed in, it didn't. Oh, there we go. So when you look at the definition of this GET request, it says that it's idempotent. And What that means really is this part here, where it says the side effects of doing n greater than 0 identical requests is the same as for a single request. Okay, that's a mouthful, but what that says is if I do the same request again, I should expect to see the same result. An example would be I just click refresh on the page. And the URL says that I'm looking for slide 6 of lecture 15 or um, something 6 of lec 15 dash post dash form. So what the get request is saying is that I expect that every time that I hit refresh on getting slide 6 from this thing, I'm going to get the same content. So it doesn't matter unless something on the server side changes. Doesn't matter how often, how many times I click refresh, I still get the same thing. Um, so that's really kind of one of the uh, things that we keep in mind when doing a GET request is that I shouldn't expect something else to change as part of my request. Now, there are some exceptions to this. For example, you could imagine that when I'm trying to retrieve the latest tweets from Twitter, that's probably going to change based on how many times I search for it. If I do a search for something on Google about recent events, I expect that it's going to be different tomorrow than it will be today. But the fundamental difference between get and post is whether or not my request causes something to change on the server side. So now we get into the notion of post. So post is where we're potentially asking for something to change on the web server side. Um, and so that makes it not idempotent because if we issue that request again, say submitting some form data, now I suspect that something will change. I have a new instance of my form data. I have a new session because I just logged in again, and so something has changed. Um, Jeremy has a question of, is the idea that get won't be different over time or that the get request won't make things change itself? Um, More the latter part of that question. So um, we might expect that over time, maybe the content returned is going to be different just because things on the server side change all the time. However, the get request itself isn't going to make changes itself. Um, Does that kind of help? I know I'd said, and the specification says that the effect of making n greater than 0 requests is the same as making one, but in reality, things are a little bit different. But the fundamental thing is that the get request isn't requesting for things to change. It's just requesting that same content. So I'm always requesting slide 6. Slide 6 might change, but I'm always requesting slide 6 and I'm not requesting that it be changed. Post, meanwhile, is requesting things to be changed. Um, and whereas in a GET request, all of the information we need for the request is up top in that URL. So we're requesting slide 6. A post request is a little bit more hidden. And so it's a little bit more secure than a GET request. And in fact, every time you see a login form of some sort, of some such, it's probably using a post request. And that's because it's taking all of the information that it wants to send to the server and it's putting it in the body of the HTTP request rather than in the URL. And what that allows is for the request to be encrypted and hidden from people who might be wanting to examine the data that you're trying to send to the server. So perfect for usernames and passwords where we don't want people to see those. And so you're likely to see these in logging into things. posting a new message to a blog where you want that to be secure, at least up until it's verified by the server that it's you, and then posted to the internet. Adding comments to videos, things like that, are almost always done in post request. And what's changing on the server side there is I'm asking the server to save some data in the case of posting a message to a blog or adding a comment. I'm asking the server, to verify that I am who I say I am and to create a new session for me. And so that's some data that's being saved, or some state that's being created on the server side. In all of these cases, something on the server side is changing. And it also allows us to say that, um, because things are changing, I also need it to be a fresh request every time. So nothing's cached with these requests. We haven't talked about caching much, but the short version is that it's where we save some information about the request on our client within our browser, so that we can save some traffic to the internet by not making that request again. Post requests are not saved on the client side because we don't know what effect they'll have when trying to change on the server side. Okay, I've talked really quickly and a lot of information really fast. It's in some ways, a repeat of some readings potentially, but I want to pause for a second to see if anyone has any questions on this difference between get versus post, and also drink some water. So Nikhil has a question of, why is Git actually less secure? For example, the NASA API, that picture of the day API that we were using, uses Get for all of its requests, including actually passing the API key as part of the URL. So why is that less secure? So typically we're not necessarily going to see API keys in the URL for APIs that need to be secure. And what's insecure about that is how it appears when that request is traveling over the internet. And I'll get to some examples where we'll open up the Chrome inspector here in a couple minutes to show what that actually looks like. But because that API key shows up in the URL, anyone can see it potentially. And so NASA and other API owners have made the decision that having API keys publicly visible like that isn't really a huge deal. And so in NASA's case, they have some logic on the back end, on their server, on their API side, that says this API key has made this many requests per hour, and if it goes over this number, I'm just going to cut it off. And it's not sensitive data; like it's a picture of the day. So I go to the NASA API and I click on the photo of the day. Like, it's a description and a photo, and these are all publicly available. So it's not so having an API key out and about in the public isn't hugely important or dangerous in any way. Um, Having access to that API key or those query parameters also don't request any changes to be made on the server. There's some analytics, sure, on how many requests that API key has made, but um, but that request is not requesting anything be changed. It's just requesting. It's saying, I am this person as identified by my API key, and I would like today's photo. So that's why they use get request primarily for these sorts of APIs. Other APIs might want to say that this API key is actually a secure thing because it allows someone to buy things on Amazon or something like that. In which case, that is a secure operation, and it requests a change to be made, which is an order is placed. So that, in that case, needs to be a post request. And again, what we'll see in a little bit is that that request data is pulled out of the URL. It's not even in the headers, and it's in the body of the HTTP request. And that part of the request is can be encrypted with something called SSL or HTTPS, and that makes it a little bit more secure, quite a bit more secure than a GET request. Does that answer your question? Excellent. Other questions about get versus post before we go on and see some examples in real life? I've got my chat over there, so if I keep looking over there, it's because I'm looking at the chat. Nope. Okay, moving on. So by default, when we do one of these requests with fetch, it is a get request. We are taking a URL, we are adding some query parameters with that question mark and some that key equals value syntax. Those parameters are visible in the URL bar whenever that request is made. And so that's what happens by default. And I'm going to open this up. And this is a simple website where we have some menu items. And if we inspect and look at the network tab, make this bigger, and I'll refresh again now that we have the network tab open. It's maybe too big. We see here that we made this request, and I'm going to change the headers that I have available here. I don't necessarily care about the initiator, but I do care about the method. We see here that we have our method of get, and I can click on that and I can see my headers where that request URL. So these headers are just sent in plain text over the internet, and anyone who's watching your network can see these things. And so we see this request URL as part of the headers, and sure enough, we are requesting menu.php with the parameters of menu equals cafe-menu. And this is aside from any get or post questions, this is a nice tool to be able to see that I made a get request, the status was 200, and a bunch of other information. And you can see at the very bottom, like we have some information here on, we had some query string parameters, and that's what it was. So that's an example of our get request as seen from the client side. So when we do a post request, this is where things get different. So thus far, we've only seen fetch with a single parameter, that URL parameter, which has potentially our query parameters. When we do a post request, we actually add a second option, a second parameter, or a second argument. All of these are valid terms. We add a second thing to fetch, and that's it's a JSON object, as you can tell by the curly brackets and then the key colon value. So it's a JSON object. These are the different options that we're passing to fetch. And in this case here, in this example, we're saying that for this fetch request, I would prefer that you'd use the method post. And in fact, please use the method post. And the body of that request, so again, post is moving our parameters from the URL down to the body. The body of that request is the things that I have created with this params variable. So I'm taking some form data. This is something new that we've introduced, but we're taking some form data. It's a particular format of request data, and we're appending a username, and we're appending a password. So again, that perfect example of why we want to use a post request is, or when we want to use a post request is username password. Um, and then setting that to the body or to the API. So when we look at doing this, I have this page here, and I'm going to inspect it to see. Um, Again, we go to our network, and if I do say, I'm going to just do my name plus a simple password. I'm going to try to log in, and you can see here in the network tab that we've now menu.php has been given a post request. And so unlike the GET request, so if we go back here where we saw in the GET request, we had menu.php question mark menu equals cafe menu. That is a GET request where all the parameters are in the URL. Here, there's nothing there. And that's because it's a post request. We click on it, we go through this, and we see that it was an invalid request for whatever reason, probably wrong username, password. And we go down, and there's nothing else here. There's just menu.php, and that's it. There's no parameters after that. As you scroll down, eventually we get to the bottom, and we see that the form data was sent with my username if fits and a password of 1234. So that's our post request where it's pushed down out of the URL and into the body of the request. Questions on that so far? Yeah. So why is it more secure if you can still see the data? And that's because this was done with not a secure endpoint where it's not actually encrypted, but also because I put it in, I hit login. If I did that with, actually, let's try to test it. I'm going to test this on a different page. So the short answer is it's visible to me because I'm on the client that submitted it. Um, it would not be visible to people outside of it. Um, Give me 1 second. Okay, coming up with an example on the spot is more difficult than I anticipated, but um, uh, it's still stands what I was saying earlier that it's only visible because I'm on my client. If other people were inspecting my traffic, it would not be visible. And trying to set that up so we can see it happen, it takes more effort than on the spot. I don't have those programs open right now. So I can follow up afterwards with an example of what that actually looks like if we were to try to inspect that data and see what it looks like. So thank you for the question. I will follow up with that afterwards. Other questions about that? Anyone? Okay. Um, so um, the example that we saw here on this slide is uh, hard coding. It's manually creating this data that we're sending back to the server with. We have these hard coded strings with the username and password just here in the code, but that's generally not what you're going to do. In fact, the this page is doing it a little bit differently, and it's not just hard coding my username and password or even this username and password into it. Um, and that's because obviously with username and password, we don't have those stored in the source file. We have them stored in some kind of secure database on the back end, hopefully. And so what we really want to do is pull out that information from a form and then send it that way. And when you're looking out on the internet for information about how to do this, you're probably going to see at least a couple of different ways. Um, and so I'm going to address this really briefly. The older way is to see something that looks like this, where you have a form and you're requesting, let's say, city, state, zip code, and you hit submit, and the form HTML element has a method attribute. It has an action attribute, and these things are saying that when the submit button is clicked, or when the form is submitted, I want you to create a post request, and I want the thing that handles that post request to be the action parameter. And so one of the downsides about this is that if I go to this and I click submit, um, my form is immediately lost. I have nothing there. And granted, I clicked on this and had nothing in the form. So of course it gives me an error that the things were missing. If I actually fill that in um, with some real data, um, we can get some information there. But if if I mistyped it, I can hit back, and fortunately, my browser here saved my data, but it doesn't necessarily. It just like we don't get any kind of validation here. We have to refresh the entire page, and everything's gone. Um, it's kind of annoying, and it's particularly annoying because we use JavaScript to be able to handle asynchronous features like exactly this. There's a reason fetch exists and why promises exist and async await. All these things allow us to do things that happen at some point randomly in the future. And so having the page totally refresh on this is kind of frustrating. That's one way you'll see it. The other way you're going to see it is kind of like this. So I'll go back, and it's the same thing, but just with a different uh, front end. So now when I click it, I get this response back, and I still have my form here to use. And this is using our now introduced new way of submitting post data, where we're saying, I'm just going to look at the form and I'm going to construct a new form data out of that. And the nice thing about the form data object in JavaScript is that we can just pass it a form and it'll pull in all of the parameters from that, create a new form data, and we can send it along with the fetch request. Um, and so there's some upsides and some downsides to using either one of these methods. Um, and just quickly in chat, what do you think would be a particular downside of using this older version where the entire page refreshes when we click submit? Yep, we've got that bandwidth usage it's a new request, so we use more bandwidth. If you mess up, yep, the form is gone. The password is wrong. Yep, you've got to go retype both the password and the username. all of your input disappears. The runtime is definitely an impact there because we have to re-request the entire form when we come back to it, potentially, or totally resubmit. If there's a typo, yep, we have to resubmit everything. Um, and we're not separating behavior and content. These are all great reasons for why this particular version isn't wonderful. Mostly, it's the feedback back to the user, and that's the most common thing that you all said in the chat here was uh, when I mess up, when I typo something, um, it's really annoying. I've got to, look at, oh, there's an error here. I've got to hit back. I've got to refresh. I don't know what the error was because all my form data is lost and now it's gone. And that feedback to users is kind of the most important part of that. Um, and so that doing this method where we are using our fetch request and having all that data still on the page and where we have the page loaded on the client side, we don't have to overload the server with needless requests. We can just do some of that validation right there. And so when you uh, actually look at implementing this, what we'll have to do is add an additional line of code here to make sure that things don't refresh on us. Because again, that refresh point was the sticking point for the difficulties of approach number one. And as I said, that approach works on the basis of waiting for that submit button and taking all the data and sending it off to the new page and refreshing everything. And so what we want to do here is add this event.prevent default line here. And so what we're saying there is that the submit action for the form needs to not do its default behavior. I want to override that behavior and do something myself. And that's going to be issuing the fetch request with the post method. And I want to not submit this form. I'm going to handle it myself. I want to prevent the submit button's default behavior. So there's a difference here between the click and the submit in what happens. So a click event by default doesn't really do a whole lot. It registers a click. Maybe it has some so like the mouse down button here has some actions on it or some animations on it, so we might see like that button get depressed or something like that. The click by default doesn't do a whole lot. The submit, however, is a special thing on forms where it's actually going to try to collect the data and send it off to the action. It's saying this page is done, I need to submit it to where it needs to go. And so it's going to do some extra things like going to the next page or refreshing or things like that. So that's where it's a little bit different with submit versus click. It's mostly used with forms. You can force that behavior in other situations, but it's almost always, if not always, used in forms. Okay. And so once we've prevented that refresh behavior of our submit button, we can do a bunch of things on our form, on our client side, without having to worry about losing all the data the user just put into the form. And so this is this notion of input validation, and we'll primarily talk about it today on client side. And when we look at it next week, we can see what it might look like if you need to do things a little bit more complicated and maybe do things a little bit on the server side. Username and password is a perfect example of that. And so try as we might to develop a very good form. We might have, for example, I guess I have it here. We have a form that's clearly labeled that I want my city. I have clearly labeled that I want my state, and I'm clearly labeled that I want my zip code. Try as we might, people will and often do write things in some other way. They just write it how they want to write it, and they're not always going to follow exactly what your form says. And so we need to do a little bit of validation here. And so I know it's a little bit of a small image, but um, what kinds of things would need to be validated in potentially a form like this, um, and in what way? Okay, we could have a regular expression on email addresses. Different kinds of characters are maybe allowed in names versus emails. Passwords, we may have um, requirements on what kinds of characters they have. The password and confirm need to be the same. Yeah, so all of these things are good. Yeah, so we could have email address needs to be at least certain length. Password can be no more than length. Although you shouldn't restrict a password on how long it should be. It can be very long, and that'd be great. But we might want to set a max on certain fields. The zip code field, for example, we might say yes, it's always 5, at least in the U.S. Um, for city state, yeah, we could validate that it is a city state that we allow for this particular use case. Um, so yes, these are all great examples of why this form or what kinds of things a form should be validated in or with. So uh, these are the examples. Some other examples we came up with. So that min length of saying email address should not be 0 length. That the currency, if we wanted it, is only numbers. The postal address is only numbers or certain letters in other non-U.S. Postal districts. Um, and so these are all great examples of validation. And there's a couple different ways we can accomplish a lot of these. Um, here's a real world example where it's actually giving feedback to the user in real time. Um, and before we get into how that happens, it's important for a few reasons. Largely because it's user friendly, as we've kind of identified earlier. It can be super annoying when you type something in and you hit submit and it's all gone. And so having some validation on the spot is really helpful. Um, it's also a way to improve security so that you're preventing certain kinds of data from being sent in the form, or that you are making sure that the input is actually safe and isn't going to break other things. And so all of these are very important. So here's an example. It's a very simple, a simple version of the form where it's a form. We've got our labels, and in particular, we're adding here some certain kinds of types. And I don't know if you noticed in this form example, when I clicked here, I had these arrows up and down, so I can click these arrows up and down, and my number changes. And this is all because we put this new attribute onto the input type where it's saying it's a kind of number. It's the most basic kind of client-side input validation we can do is just restricting whether it's a text or a number. Um, and then once we hit submit, then we can use some JavaScript to do a little bit more processing. But there's still more we can do in HTML though. Oh, and these didn't come out very cleanly at all. So the first one is to look at what type we're looking at. Now I will clean up these slides. Uh, and so Nikhil has a question on, doesn't this break the rule of separation of content? This is one of those areas where it gets a little bit murky. But when we're doing input validation with things provided by HTML5, the way I think about it is it's still about content, not about behavior. And that's because I'm declaring what I expect the content to look like. And so it's still declaring meaning and metadata about the content. So, for example, this first line is saying that, and I know it's hard to parse because there's extra tags here, but this first example is saying that I need a type of number. So it's not saying anything about what happens when it's not a number, but it's saying that this particular field is a number. Likewise, the second one is saying that I'm not defining what necessarily happens with when a number is too big or too small, but I am declaring that I'm expecting a number between 0 and some kind of max. So I'm not doing anything. I'm not submitting it. I'm not changing the DOM. I am just putting restrictions on the content. So it's still separated. Does that answer your? Okay, excellent. And where it starts to get a little bit murky is when we get into things like required, where we're saying that this field has to exist. And so this form should not be submitted and really ought to be filled in before you're able to submit this thing. Then we start to get into more complicated things like a regular expression, where we can specify some more complex rules about how these things look. And again, I'll clean up these slides afterwards because it got a little messed up. But here's that same form with a little bit more basic validation on it. So we're saying that the state has to be only 2 letters. And in fact, if I try to type more letters, it doesn't let me type anymore. And so I'm trying to type a 3 and it doesn't type a 3 because I only limited it to 2 letters, 2 characters. And the zip code, since we're in the US and we do 5-digit zip codes that start with 10,000, we're saying both that it's a length 5 number and that it must be from 10,000 to 99,999. And that means that I can type in these small numbers. I can type in a single character here. Then if I were to, well, if I like left that off, for example, now my browser is interpreting this content to give me some information on what's going on because this field is marked as required and I didn't actually give anything there. So this is some basic HTML validation that we can do. And so there's in the slides, and I know we're running short on time, but in the slides, there's an example here that you can play with a little bit where you can enter a queue for WPL. And so it's a real basic form with a few different types of data. And here's the source code for it. Here's that link there. The form for this is doing a bunch of different validation on it. We're defining mins and max. We're defining whether it's required or not. And then the JavaScript is preventing the default from the event so we don't refresh the page every time we submit. But then, and then it's taking it from that form with that form data and submitting it out. We could also look at manually constructing that form data, kind of like that first example did with the username and password, but using our query selectors instead of the form data. So if for some reason your HTML does not have a form but has a bunch of input fields, you can still do the same thing by just constructing this form data manually and sending it along. And so this is generally going to be our pattern of how we look at posting data to an API. And when we get to working with them next week, we'll see how to actually do something with it on the back end. on a server that wants to process them. So that brings us to our time for today. Thank you so much for being with us. I noticed that I forgot to start the recording, and someone picked up on it about halfway in, and I do recognize that that means some of the first content got missed. I will re-record that and upload it separately, and see where we got to. So I apologize for anyone watching this at this point that the recording didn't pick up everything, but we will remedy that. So that's our day for today. As usual, we'll stay on for a little while to answer any questions. And thank you so much for coming today.